We consider now a second scenario where there's a pollutant flowing through groundwater or diffusing through groundwater. And we're going to focus on this term we have not used yet, the right-hand side. That f of x is going to be used when there's some external influence on the natural diffusion process. Now, first of all, what kind of units are we talking about here with that function of x? Well, if we look at the dAc double prime, diffusion coefficients are measured in meters squared per second, areas are measured in meters squared, and C double prime is interesting because we have a concentration, parts per million, but you have to be careful which derivative this is. C is a function of x. So when we talk about the second derivative, we're talking about two derivatives with respect to x. And what that means is that the units are dividing by what the derivative units are. So x here would be in meters, a distance. So we'll actually divide by meters squared twice. And all of that together is going to give us parts per million per second times some unit of area. Now, are we consistent? Hopefully we are. If we take the second term, a v c prime, we have meters squared. The velocity usually is in meters per day or hour, but let's keep it as units of time of seconds for consistency. And the concentration would be parts per million with one derivative with respect to x, which divides by 1 unit of distance. And all this together gives us parts per million per second and 1 meter squared still left standing. And so what that tells us about the units of f of x, if it's going to be equal to these other two quantities, it's going to be in that same parts per million per second with some influence about area of exposure, presumably. Having seen what these units are, well, this sounds like almost like a leaching in rate. In, or possibly out. If we imagine our tunnel here of sand, or our layer of sand, if there's some kind of input of pollutant in the middle, and it's not represented by the end conditions, which would be concentration at this end and concentration in our earlier example of 1,000 meters away, that would be captured by f of x. And so if f of x equals 0, there's no additional pollutant involved. But if we have something being added in the interior, it's going to be represented with that f of x. What we're going to look at next is an application where we imagine that there's some kind of pollution being injected into the system at an interior point, and we have the measurements, say 2 streams at either end, where the pollution's being washed away. We can determine then what the gradient of the toxin or the pollutant is over the entire sand bed.